welcome to Learning with PPS. So in this video we are going to talk about the deadlock in operating system. So deadlock is a situation where two or more processes are waiting for some other resources. That resources are held by some other process. Okay, so in the situations none of the process gets executed. The system becomes unresponsive, then all process are got blocked. This is the exact situation of the deadlock. In these situations none of the process got executed, all those process are got blocked. Okay, these are all the necessary conditions for deadlock. So deadlock occurs when four conditions are met. One is mutual exclusion, hold and wait, no preemptions, circular wait. Mutual exclusion, only one process can access a resource at a time. No preemption in the sense resource cannot forcefully taken away from the processor. Okay, hold and wait in the sense a process holding on resources can request additional resources which was used by another process. Circular wait, a process are waiting for the resources in a circular manner. So in the image itself you can identify that this is called a circular wait. So here P1 is waiting for R2, but R2 is assigned to P2. P2 is waiting for R3, R3 is assigned to P3. P3 is P3 want R1, but R1 is assigned to P1. So this is the way all those processes are waited in a circular for getting the resources. Okay, these are all the necessary conditions of deadlock. So whenever we want to prevent the system from deadlock, we must break any of the four conditions. One is resource ordering. So process requires the resources in predefined order. So which means we can prevent the circular wait. While creating the process has to inform these are all the resources I am going to use during the execution. That is called as resource ordering. Resource allocation graph, it is a pictorial representation of the resources, visualization of the potential deadlock. Banker's algorithm, the resource allocation algorithm that check if the granting resources request would lead to a deadlock or not. Simply we can say the Banker's algorithm or combination of resource allocation algorithm and the safety algorithm. Resource allocation algorithm in the sense, so now we are in the resource allocation algorithm we are going to check whether the given request is allocated to or not. Okay, safety algorithm, if all the resources are allocated to the process, the system is in safe state or not. That is called as Banker's algorithm. Okay, yeah, this is the data structures for Banker's algorithms. So there are four data structure. One is available, maximum, another one is allocation, fourth one is need. So available in the sense it indicates number of available resources, currently number of available resources. Maximum resources, which means currently the process. Okay, suppose we are creating one process, that is P1. What are all the maximum resources available for P1? What are all the maximum resources needed for P1? Allocation, currently what are all the allocated resources to the particular process? Need, currently what is the need of the particular process? These are all the four data structure most important for Banker's algorithm. So available resources is it is like a central resources. Okay, these three are, that is maximum, allocation and need. These three are dedicated to particular process. Okay, so deadlock prevention, how we can prevent the deadlock? So deadlock prevention strategies ensure that at least one of the four conditions is never met by the system. So how we can break the mutual exclusion? Share resources or use alternative resources. By implementing these two steps we can break the mutual exclusion. Prevent hold and wait. So process request all the necessary resources at once. Allow mutual exclusion. So a resource can be taken from the process holding it if necessary. break the circular weight. So assign unique number to each resources and process must request resources in the order. Okay, so this is the way we can prevent the deadlock. In GATE exam and NET exam and UGC, TN set exam, all those examinations, the most important concept is deadlock. Definitely one problem will be asked under the deadlock. Okay, so next, so we must know what are all the differences between deadlock and the starvations. So both are situations where process are prevented from progressing. Okay, so deadlock now all those processes are blocked. The starvation, lower priority process only blocked. All the process in the deadlock are permanently blocked, but that is preempted process or starved process may eventually gain the access to the resources. Okay, this is caused by the circular dependencies. This is caused by unfair scheduling algorithms. Deadlock is infinite waiting. Starvation, it may be finite waiting. Okay, whenever the OS or CPU is not receiving any higher priority process, that time the lower priority process will be executed. Okay, so this is called as starvation is finite waiting. So example diagram of representing the deadlock. Here P1, yes, here P1 hold R1 resource but it request R2. Process 2 hold R2 but it request R1. Okay, so this is the way we can't execute any other process, because if you want to complete P1 we need R2 resources, if you want to complete P2 we need R1 resources. Okay, this is exact situation of the deadlock. Okay, so in this example currently we have two process, two resources. Okay, so up to this the introduction and the conditions data structure for deadlock is over. Okay, so thank you for watching. Those who are not subscribed my channel, please subscribe my channel. In this channel I'm going to upload some of the GATE examinations questions, NET examinations and GATE and set examinations, as well as BGOR entrance test and so on. Okay, so please subscribe my channel, please share my channel. Thank you for watching.